Okay, next couple of questions. That's probability. Here we've got some batteries. Two are defective, and then here and then not being replaced. And here we've got just a calculation. So drawer contains 5 batteries, 2 which are defective. 2 batteries selected at random with their replacement. The probability of exactly one being defective is. So what we want to find the probability of exactly one being defective. So we'll make a new thing. So what we've got is we can have defective and not defective, or we can have not defective, not defective and defective. So it can be one of those two things there. I don't know why it's giving me a times and didn't do it before. Must be a CAS thing. Anyhow, there are two options we can have. We can have defective, not defective, not defective, defective. So what we want to do, we want to find the probability of it being defective. So if we have a look at it, 2 are defective. So that means initially 2 out of 5 are defective. So then as well as that, then we're going to have, if we've got 2 out of 5 have been defective, then we're going to be left with 2 out of 5. And the second one, not being defective, actually we need a tree diagram for this. This is starting to get too much. I've already set up drawing for the next question, so we'll have a look at that first. I've already set this thing up in a Venn diagram. So let's have a look. So here's our Venn diagram. It tells us that 0.3 is our overlap. So 0.3. It tells us then that the probability of B is 0.75. So this has got to be 0.45. This is A. This is B. Okay. So now it tells us that the probability of not A and not B, so that's everything apart from A and B, has got to be 0.15. So 0.15. Okay, so what we do now is we add them up together. So we've got 0.3, 0.7, 0.45 to make 0.75, plus this to make 0.9. So that means we've got 0.1 left over. Now, based on that, the probability of A is going to be 0.1 plus 0.3 to make 0.4. We have our answer there in B. Okay, let's have a look at this thing here. Try this one again. So I'm going to delete all this. And we're going to make some lines. So we've got defective and not defective. So here we have a D. And we have not D. And then once again, let's draw some more lines. We can have defective and, oops, not defective. We can have defective and not defective. So D, D, D with an apostrophe, D, and then D with an apostrophe. So over here we have got, so if it's 2 out of 5, we've got 2, if we're starting with 5, this is now 2 out of 5. This means this has got to be 3 out of 5. This one over here, if it's without replacement, so they're not going back in, we've reduced it to something out of 4, and then this has got to be 1 out of 4. Over here, we've reduced this to out of 4 as well, so this has got to be 3 out of 4 because we've got 3 non-defective ones left. Then over here, if we've pulled a non-defective one, we've got 2 out of 4 because 2 of them are defective, and that also means we've got 2 here that are not defective. So now we want the probability of at least one, the probability that exactly one is defective. So that means we are looking at D and not defective, or not defective and then defective. So we trace those through. So defective and not defective is 2 over 5. 2 over 5 times 3 over 4. And defective, not defective, defective is 3 over 5 times 2 over 4. So what we end up with there is 6 over 20 plus 6 over 20, which ends up being, so 6 over 20, so oops, can't do that. 6 over 20 times 2, whoops, times 2, end up with 3 over 5, which is our answer there. Sorry, our answer there is E.